Nowadays, the world is spending billions of dollars on building new solar plants. And some of them have very smart strategies to produce profitable electricity and to ensure that their plant is safe for the next 25 to 30 years. But what's their secret? Very simple: adhering to international quality standards. Hey everyone, my name is Sahil, and in today's video, we will discuss the components that protect your solar plant. These are the lugs, the glands, the earthing equipment, and the lightning protection systems that protect your solar project. We'll discuss the standards each component must comply with. This will help you buy the right product and ensure your solar project is safe. But why should you listen to me? At Axis, we've been manufacturing a wide range of lugs, glands, earthing, and lightning protection for over 30 years. Before moving ahead with the rest of this video, we have an ebook going into the depth and the details of how to protect your solar farm. So if you want that ebook, just click on the link in the description. Now let's move on to the rest of this video. Now let's start with bimetallic lugs. A lug is simply a component used to connect an electrical cable to equipment or a bus bar. In solar plants, bimetallic lugs are installed inside the combiner box to ensure electrical safeties. These lugs should comply with ESE 61238 Part 1. This standard specifies the requirements for electrical connectors and lugs. It tests how well the lug maintains the electrical connection under mechanical stress, temperature changes, and vibration. It also verifies that the lug does not degrade when subjected to thermal cycling and moisture exposure, ensuring they will perform reliably in harsh environments. This lug should also be tested to UL 486A and UL 486B. This standard ensures wire connectors perform reliably under thermal cycling, electrical stress, mechanical loading, and environmental exposure. These tests verify your lug is safe for electrical installations. Apart from just compliance, your bimetallic lug should be friction welded, which creates a metallurgical bond and prevents corrosion. Since bimetallic lugs are a combination of aluminium and copper, you must ensure that the copper is ETP grade with 97% minimum IACS copper conductivity, and the aluminium is EC grade with 60% minimum IACS conductivity. Avoiding these specifications will compromise the safety of your solar plant. If you want to learn more about how lugs are tested and manufactured, you can check out some of our videos about how we do the testing of lugs at Axis. The link will be in the description. Now, cable glands. A cable gland is a component used to seal and secure cables entering an electrical enclosure or combiner box. In solar plants, glands must be heavy-duty, weatherproof, and flame-proof to protect against harsh environmental conditions. To ensure electrical safety, these glands should comply with ESE 6079. This standard specifies requirements for flame-proof glands. It covers the construction and testing of glands designed to use in explosive atmospheres. This test ensures your gland can withstand internal explosions and pressure without compromising safety. Also, ESE 60529. This standard tests how well your gland seals against water and dust ingress in harsh outdoor conditions. It should have a minimum IP rating of 67. Axis glands have IP68 compliance, which provides even greater protection in submerged or extremely humid environments. BS 6121. This standard ensures armored cable glands connect armored cables to enclosure. This testing ensures that the glands maintain mechanical integrity under installation stress. It also makes sure that the glands withstand extreme temperatures and corrosive atmospheres. If you find this video helpful, please subscribe to our channel for more insightful videos on electrical engineering. Now, earthing. This is a process of connecting your structure's electrical system to the earth. It provides a low resistance path for fault currents, protecting your equipment from damage. To ensure your solar project's earthing system is safe and durable, your materials should comply with the following standards. These materials include your earth rods, your clamps, your pits, and the compound. IS 3043. This is the main Indian standard for earthing. It explains how to design, install, and test earthing systems for electrical installations. It covers soil resistivity, electrode sizing, conductor selection, and testing methods. IS 1772. This standard specifies the material requirements for copper alloy earth rods, and plates for earthing. It defines the material properties, dimensions, mechanical strength, and electrical conductivity that your earth rods must meet for ensuring electrical safety. UL 467. This UL standard defines the testing and performance requirement for grounding and bonding equipment. It focuses on conductivity, corrosion resistance, and mechanical strength to meet internationally accepted quality benchmarks. If you want to learn more about the testing and the testing standards of earth rods, you can watch our videos linked in the description. In these videos, you will see the testing of the Axis UL listed earth rods in our UL listed laboratory. Now let's discuss lightning protection systems. These systems protect your structures and equipment from lightning strikes and the resulting surges. So let's understand the standards that we can use to protect your solar projects from lightning. We will start with conventional lightning protection methods, followed by the ESE technology. ESE 62305. This is the foundation for designing lightning protection systems worldwide. It covers risk assessment, external protection, internal surge protection, and the safety of people and equipment. This standard has been adopted in India as IS-IEC 62305. IEC 62561 Part 1 to Part 8. This standard defines the performance and testing requirements for all components in an external lightning protection system. It covers air terminals, clamps, conductors, earth rods, joints, and test points. These standards apply across your system, covering materials, installation methods, and component testing. If you want to learn more about any of these testing methodologies, including IEC 62561 or IEC 62305, you can check the video in the description. Next, ESE lightning protection. NFC 17102. This French standard explains how to select, place, install, and maintain early streamer emission lightning arresters. It provides methods to decide the protection area and layout based on the conditions. We also have a detailed video on the testing requirements of NFC 17102 2011. The link to this video is in the description. I hope you now have a brief understanding of the standards that will protect your solar project. The majority of the tests we discussed are performed at our NABL accredited and UL approved in-house testing lab. We never compromise on quality, which is why millions of our solutions are installed in solar projects across the world. And we have a team of 50+ engineers who are here to help you in designing, installing, and testing your lugs, glands, earthing, and lightning protection systems. Please share your feedback and queries in the comment section below. Don't forget to like and subscribe to our channel for more videos about solar protection and other electrical engineering topics.